In this video, we're going to talk about graphing 3D equations on your x, y, and z axis. To start, we're going to go back a little bit to what we did when we had two variables graphed on your x and y axis. So this is in the form of y equals mx plus b, your standard slope-intercept form, and we're pretty good at graphing those by this point, I hope. And so you start with your x-intercept of -1, and then from there you use your slope to go up 3 and then over 1 for over and over and over to create your points so that you can graph your line. So that's with your slope-intercept form, but what we're going to be focusing on is things that are in the standard form. So if you have the form 3x plus 4y equals 12, this is what we consider standard form, and you want to try to graph this line. Well, you could put it into y equals mx plus b form, but there's another way. Another way is to find out what your x-intercept is and to also find out what your y-intercept is. So when you find these, you can then plot them as points and then draw your line between them. So we know that at every x-intercept, your y value is equal to 0, and every y-intercept, your x value is equal to 0. So to find your x-intercept, you're just plugging 0 in for y, cover that up. You know that it is going to be 3x equals 12, or x is equal to 4. For your y-intercept, x is equal to 0, so you cover that up. 4y equals 12, and y equals 3. So we can plot those 2 points. You can plot 4, 0, and 0, 3 as 2 points, and then that would be how you could graph your line from there. So that's graphing from standard form. So let's take that to the next level as we start to look at graphing these 3 equations, or these 2 equations with 3 variables rather. So we have 6x plus 4y plus 12z equals 24, and we're going to graph that on our isometric dot paper. Now, not only do we need the x and your y-intercept, we also need the z-intercept. So at any x-intercept, we know you're going to have a number and then 0 and another 0. So you're going to put 0 in for both the y and the z. For your y-intercept, 0 something 0, and z-intercept 0, 0 something that we're going to try to find out. So same idea here. To find your x-intercept, you put 0 in for both the y and the z. So 6x equals 24. So that will help you figure out what that is. 6x equals 24, so x equals 4. And you repeat for the others. Zeros go in here for your y-intercept. So 4y equals 24 or y equals 6. Zeros go in for x and y. 12z equals 24 or z equals 2. So now that you have your 3 intercepts, you can plot those as points. 1, 2, 3, 4, 0 on your x-axis. 1, 2, 3, 4, 5, 6 on your y-axis. And then up 2 on your z-axis. And all you do is you connect those with line segments between those points, and that would be your plane. So what this represents is that you have a plane which is cutting through your x, y, and z axis, and you can kind of shade it in there if you'd like to kind of show that it is a 3-dimensional plane. So you repeat over here, find your x, your y, and your z-intercept. You know where the zeros go for each of those intercepts, and then you plug those in to be able to solve. So 0 goes in for y and z, which means x has to equal 5 for your x-intercept. Same idea for y. Y has to equal 5 as well once you plug zeros in for your x and z. And then for your z-intercept, you plug zeros in for x and y. So 10z equals 20. So therefore, we have z equals 2. Again, and so now you plot these points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2. And then you would connect those points with line segments. And you can shade in to show that this is a plane that exists in 3-dimensional space on your x, y, and z axis.